last 10.5 years, and I've been training people on Teradata for the last 5.5 years. So this is about myself briefly, and welcome you all for the Teradata training demo session. So in this Teradata demo session, I would like to walk you through the significance characteristics of the Teradata, why Teradata is popular now in the industry as a data warehouse database, okay, and why all the industries are looking at Teradata to implement their warehouses on Teradata RDBMS. Okay, so those things we will briefly walk you through for the first 30 minutes, and then I will walk you through the course curriculum, what the course curriculum for the rest of the training sessions, and then I will open up for your questions. Okay, then you can shoot me with your questions and can clarify if you have any questions. So let me start with the Teradata significant characteristics. To start with, let us consider a simple business scenario. Everyone knows the banking business, I hope, right? So what a bank does a simple business of lending money and collecting interest. So that is the core business of the bank. So we will consider a multinational bank which is across the world, and we'll see what is the business and how the data growth exists for a multinational bank, and what happens if we don't store that data properly. Okay, so let's consider a multinational bank which is having branches, okay, almost 10,000 branches across the world, and each branch has 1 lakh customers. And if you consider each customer transactions, okay, then on an average, if a customer does 2 transactions per day, okay, so we are considering all the products of the bank such as credit cards, debit cards, okay, deposits, trading accounts, everything. And if you consider the transactions of all these customers, then we may consider, okay, each customer can do on an average 2 transactions per day. Okay. Then if we need to calculate the number of transactions per the bank per a day, we have to do a simple calculation like 2 multiplied by 1 lakh customers, and the 1 lakh customers multiplied by 10,000 branches. So it would come to around 2 billion transactions. Okay, so per a bank, per a day, we will have 2 billion transactions per day. Okay, if I have 2 billion transactions, then automatically the number of records would be minimum of 2 billion or maybe more than 2 billion, right? Because some transactions may require more than 1 record also. Okay, if you consider fund transfer transaction, okay, it has to affect 2 records. It has to debit 1 record and credit 1 record. So similarly, if we do a share transaction, trading transactions, it may affect more than 1 record. Okay, like that. If we have 2 billion transactions, the number of records produced would be more than 2 billion, obviously. Okay, so if we have these many transactions happen and this much of data produced in a day for a bank, we have to have a sophisticated systems to store this data for analysis purpose and for the transactional purpose, right? So to maintain these many records, what an industry would do, okay? A bank would have a RDBMS system which stores the data in the disk memory. Okay, so it contains the memory and which can store the data, and the disk memory is associated with the processor. Okay. Let's suppose on first day of implementation of the transaction system, we have 1,000 records in the system, and to process these 1,000 records, the associated processor of a particular capacity takes 1 second. Okay. And then after 1 week or 2 months, the data would increase. Okay, let's suppose it is increased to 10,000 records. Now, how about the processing time? Would it also increase? Yes, proportionally, it also has to increase to 10 seconds to process 10,000 records. And then, after 2 months or 3 months, the number of records would be increased because the transactions happening for the business. So, the number of records would also increase. And obviously, the processing time of those increased records would also be increased in a proportional way. Okay. So let's suppose at the initial invocation of the bank, okay, I am the customer of the bank and I have an online portal to do all my transactions. Okay, as a customer, I can do all these operations or all these transactions through online. Okay, I can view my account statement, view my account balance, do fund transfers, everything. Right? So when I join the bank as a customer and when I do my fund transfer transactions, okay, it was taking 2 seconds, let's suppose. Okay. But now after 2 months or 3 months, as the data increased and as the processing time is also increased, now if I do my fund transfer transaction, it is taking 20 seconds. Okay, as a customer I may be okay with the 20 seconds of transaction time. Okay. But later, after 1 year, the data is increased to some millions, and then obviously the number of seconds to process the data would also increase. Okay, now if I do my fund transfer transaction and if I need to wait for these many number of seconds, can I be a happy customer for this bank? No, right? So the operation, the transactions which I used to do in 2 seconds, now it is taking these many number of seconds. I cannot be a happy customer with the bank and with the transactions. Okay, so for the bank, there is a risk that it may lose the customers if they don't process the data within time. Okay, then what is the solution here in the transaction system? Okay, in the transaction system, there is a solution that they can keep a threshold on the storage of the data in such a way that it would store only a particular number of records or a particular period of data in the memory, and the rest of the data would be archived and kept in another system called analytical processing system. Okay, so the transaction system is called as online transactional processing system. Okay, and when the data increase beyond the thresholds, there is a risk that the customers would be unsatisfied and they may leave the bank as customers. Okay, so the solution, what they can do is they can archive the older data based on period or based on the number of records to be stored, and they can keep that data in analytical system. Because for doing the transactions, we need very much recent data. Okay, and to analyze the data, we need historical information. Okay, so to do the regular operations, regular transactions, okay, we need only the recent data. So we'll ensure that recent data would be existing in the transaction system, and the remaining historical data will be kept in the online analytical processing system. Okay, so every day I'll be archiving the oldest data of the transaction system and keep it in my analytical system. Okay, let's suppose on the first day of my analytical system, I have this many number of records, 1 lakh records, and as it is very much sophisticated when compared to the transaction system, it is taking 10 seconds to process all these 1 lakh records, let's suppose. Okay. And then as it is the analytical system, every day the data would be archived from the transaction system and kept in analytical system. So the data in analytical system also would increase. Okay, so obviously the processing time for processing the data in the OLAP system would also increase in the proportional way. Okay. So by having the solution of archiving data in the transaction system and keeping in OLAP, I made all my customers happy here. Okay. So who are using this transaction system? All the customers and clerical users who directly serve the customers. So all those customers are happy here because I have a threshold so that it would always be maximum of 10 seconds to process any transaction. So I have given a solution here so that everyone happy, the users of transaction system. But here I have the similar scenario, and who are the users of this analytical processing system? The users are the executive users of the organization, such as CEOs, CFOs, CTOs, okay, who all are responsible for the critical decisions and who all are responsible for the growth of the business. Okay, so these people, the executive management, would use this analytical processing system to analyze the data, to see the trendings, to take the critical decisions whenever it is necessary to survive in the industries. Okay, so initially to survive, and then to increase the business. Okay, so here when I started my warehouse, I used to get these trending reports within 10 seconds, but after 1 year or after 6 months, because of the increase in the data, the same report is taking 100 seconds now. Okay, it may be fine, but after 2 years or after 3 years, the data has increased like this, and proportionally the processing time is also increased. Now, if the executive user tried to pull the same report which he used to pull within 10 seconds, but now he has to wait these many number of seconds for the trending report. So can he happy now? Because as they are the executive users, the time is very precious for them. So we cannot make them wait this much time for a single report which used to generate in 10 seconds earlier. So what is the solution here to make our executive users happy? Okay. So that is the problem for the industry in the analytical processing systems, okay, in early 1990s when they come up with the data warehousing concepts. Okay, so for this, to make a solution, Teradata has come up with a patented software called PDE, that is Parallel Database Extension. Okay. So this is the traditional system, the traditional RDBMS, which could be Oracle, SQL Server, DB2, Sybase, anything, okay, which has a memory and associated processor. Okay. And when compared to the Teradata system, they come up with a software, a patented software called Parallel Database Extension, by installing which on the Teradata hardware components, the processor starts behaving as multiple processors. Okay, so these are the software components of the processors, but can do all the operations that a hardware processor can perform. Okay, so let's suppose the PDE made this processor to behave as 3 different processors, but these are not the hardware components, these are the software components of the processors. As these are not the hardware components but can do all the operations of the processor, they are called as virtual processors. Okay, so these are virtual processors which can do all the operations that a hardware processor can perform. And in similar way, the disk memory would also start behaving as multiple disks of software components which can perform the hardware disk tasks, but as they are not hardwares, the hardware components, these are called as virtual disks. Okay. And each virtual processor is associated with a virtual disk. Okay, the association you can see with these arrows. Okay, each virtual processor is associated with its corresponding virtual disk, And all these virtual processors are independent. They can work independently to process data in their associated virtual disk. Okay. All virtual processors can run parallelly, can execute parallelly on their own associated virtual disks. Okay. And the data, okay, which is 1000 records, okay, these 1000 records would also be distributed across all these available virtual disks almost evenly. Okay, so there are techniques in Teradata, yeah, how the data of the table or of table the data of the database would be distributed across all the available virtual disks almost evenly. Okay, so let us suppose these 1000 records are distributed across these 3 virtual disks with this proportion. Like in the first virtual disk 350 records, second one 350, the third virtual disk 300 records. The total 1000 records. Okay. And now if I populated all my 1000 records which were in the traditional system in Teradata, and they are distributed across the available virtual disks in this proportion, and if I execute a query to select the data of this table, okay, the query would be given to all the processors, and all the processors would run on their corresponding virtual disk, okay, to pull the data of the corresponding table. So now, how much time this virtual processor would take to process the data in its own associated virtual disk? Okay. So when compared to the traditional system, okay, 1000 records to be processed within 10 seconds. So as this virtual processor can also do the same task with the same performance, okay, to process the 350 records, it would take 3.5 seconds. Okay. And similarly, the second virtual processor would also take 3.5 seconds. And then the third virtual processor would also take correspondingly 3.0 seconds to process 300 records. Now, what is the maximum time taken to process all my 1000 records through my Teradata system? It is nothing but the maximum of time taken by all the virtual processor to process their own associated data. So it is 3.5 seconds. Okay. With the traditional system, I process my 1000 records within 10 seconds, but with my Teradata system, I process the same 1000 records within 3.5 seconds with this parallel architecture of the Teradata with the virtual processors and virtual disks. So how much performance I got here? Almost 60%, I could say. Okay, so the Teradata system comparatively 60% better compared to the traditional RDBMS system. Okay, if the processors start behaving as 3 virtual processors. Okay, so now they come up with more sophisticated system where a single processor can be treated as more than 3 virtual processors. So it could be more sophisticated, okay, and more performance we can get with those systems. But for example, and for understanding purpose, we have considered a Teradata system where we have 3 virtual processors here. Okay, so it is 60% better when compared to the traditional system. Okay, and let us consider for a long run of the business. Okay, for the traditional system, we'll be happy up to 1 year, let's suppose. Okay, after 1 year, we may hit the performance problems. But if I implement my Teradata system, okay, I could be happy up to 7 years because it is almost 70 times or 7 times or 6 times better than. Okay, let us consider 6 times. So almost 6 years, I could be happy with my Teradata system. Whereas it was only 1 year with the traditional system. So this is the first benefit we are getting. But after 6 years, even I implemented Teradata to have my data warehouse hosted. But after 6 years, I would be hitting the same performance issue. Then what is the solution? Right? So to have that problem solved, Teradata has come up with a technique called scalability. That means I can go and purchase one more Teradata license, and I can do a plugin with the existing system in my organization like this. So now my system is having 6 virtual processors and 6 virtual disks. So the association would happen in terms of memory also. Okay. So now this is my entire Teradata system, not only this part. I have purchased one more Teradata license, and I have just plugged in with the existing system, and I just reboot it. So my Teradata system is now having 6 virtual processors and 6 virtual disks. Okay. And the data would automatically distributed across 6 virtual disks evenly. Okay. Like this: 150, 200, 150, and proportionally the virtual processor would take 1.5 seconds now, right? 2 seconds, and then again 1.5 seconds, and here 150, 1.5 seconds, 2 seconds, 1.5 seconds. So I have 1000 records again, but I have increased my hardware and software capacity of the Teradata system, and to process these 1000 records with my new system of 6 virtual processors, it is taking 2 seconds. Okay, the maximum time taken to process all these 1000 records is 2 seconds. So how much performance I got here now? Is it almost 40%? Yeah, so 4 more years I can be happy. So 6 plus 4, 10 years. So after 10 years, if I hit the same problem of performance, then what I can do? Again, I can purchase one more Teradata system and plug in and then reboot. The all data would be distributed across available virtual disks, and the time required to process the data would be decreased. So I can be happy for 4 more years or 5 more years based on the sophisticated systems you buy and plug in with the existing systems. Okay, so this property or this characteristic of Teradata is called as the scalability. You can scale the system. Okay, initially you can have a Teradata system with 1 TB of memory size, and then once your business increased, your transactions increased, your reporting capability increased, your number of users increased, you can buy one more Teradata license and plug in with the existing system and reboot it. It would become more sophisticated system. Okay. So with the parallelism of the Teradata within the architectural components, you got the first benefit of performance, and then with the scalability, you got second advantage of the Teradata, where you can scale your systems up to infinite. Okay. So these are the 2 major characteristics, and there is one more best characteristic of the Teradata that is called as data protection. Okay. So for any organization, data is very much valuable, right? It is not hardware, not software, not employee. Okay. Even a hardware loss happen, even a software loss happen, even an employee resign the organization, it is not a big problem for an organization. But if they lose the data, can anyone get the data back? No, right? So data is very much important for any of the organization. Okay, so we have to have a sophisticated techniques for the data protection. So Teradata has the sophisticated data protection techniques. Okay, as it has these many number of components, okay, there may be a risk of failure of any of the component at any time. Right? If the number of components increase, then the risk of failure of any of the component may also increase. Okay, so to mitigate that risk, Teradata has come up with several layers of data protection. Okay, so the data protection in case a virtual disk fail, okay, in case a virtual processor fail, in case a system with multiple nodes would fail. Okay, so this is called as a single node, let's suppose. Okay, and if we have multiple nodes combined like this, it is called a massively parallel processing system. Okay, a single system is called as an SMP, that is symmetric multiprocessing system. Okay, if I consider the system up to here, it is a single node. Okay, the single node is called as symmetric multiprocessing system. So within the system I have processing which does in parallel fashion. Okay, that is symmetric multiprocessing system, SMP. And if I increase my system with multiple nodes, it is called as massively parallel processing system, because each single node is having parallel capability. Now I am combining other nodes also which is having parallel processing within it, so it would become a massively parallel processing system. It is called as an MPP. Okay, so in case of an MPP system, there may be a possibility that a single node would fail. Right? In such case also, Teradata has the risk mitigation technique. Okay? And it has transaction level data protection. It has table level data protection. All these levels of data protection also implemented in Teradata, which makes the data very much protected for the organization. Okay, so these three are the major characteristics of the Teradata, okay, which made all organizations think about their data warehouse to migrate from the existing RDBMSs to the Teradata RDBMS. Okay, so we'll be going through this course curriculum for the next 30 days probably. Okay. So we'll start with introduction of the data warehouse, the transaction system, the analytical systems, okay, how the modeling would be done with the Teradata, okay, the physical implementation, with some basic warehousing concepts we cover in the introduction part, and then we start with the actual Teradata architecture, okay, where we'll go through the hardware and software components, okay, AMPs, PEs, vprocs, binaries, okay, whatever we have seen, we'll give a technical name and we'll try to understand the responsibility of each and every component there in the architecture. And then we'll see the data distribution. Okay, you have identified the significance of data distribution in Teradata, right? So if we have these number of records, it has to be distributed across the available disks evenly. Okay, if we fail to make this data distribution happen evenly, then it would be as good as the traditional RDBMS. Okay, so we have to be very much careful to distribute the data across the available virtual disk. Then only we can get the performance of the Teradata. Otherwise, it would perform as a traditional RDBMS. Then there is no point of using Teradata. Okay, so we'll see the data distribution techniques, okay, with the help of understanding the indexing. Okay, indexes, unique primary index, non-unique primary index, secondaries, non-unique secondary index, partition index, and there are other indexes, okay, which will be covered at the end of the sessions. Those are join index, hash index, aggregate index, and all the other indexes will be also covered. Okay, index is the heart of Teradata basically, so we have to understand the indexing concept very well. And then we have data protection concepts. Okay, what happens in case of a disk failure, in case of a processor failure, in case of a node failure, and the database transaction failure. All these levels of data protection we'll try to understand in this session. And then the multiple types of spaces and tables. Okay, we have virtual tables, we have global temporary tables, okay, normal temp tables. Okay. So we'll understand what type of table would take what type of space. Okay, we have different types of spaces also in Teradata for the terminology. Okay, we'll understand those parts. And then we'll start with the SQL. Okay, here SQL, we are not going to start with the basics of ANSI SQL. We'll just try to start our SQL by comparing with the Teradata. Okay, I hope everyone knows the SQL. Okay. So what we'll do to make the basic users of SQL and to have the advanced users of SQL. Okay, we have designed our SQL curriculum in such a way that it goes with the comparisons. Okay, we'll first see how the ANSI SQL would look like, and then how the Teradata SQL would look like. So we'll see only the SQL which is existing in Teradata, not in ANSI. Okay, so there are some extensions of the SQL which Teradata system would only perform those operations, the merge operations, okay, some aggregations, the OLAPs, which are extended to Teradata. And then we'll see the normal ranking functions, the cumulative sum, moving sum, the reporting, the OLAP level Teradata functions. Okay. So in the SQL part, we'll cover basically the ANSI and Teradata differences, and then the advanced Teradata extended SQL. We have documents and we have presentations for each and every topic here. So once we cover the SQL, we start with the Teradata tools and utilities. Okay, SQL Assistant, BTQ, fast load, fast export, and multi-load. Okay, for each and every utility, you will see the basic functionality, what are the operations you can perform with each and every tool, okay, how to execute it, how to debug it in case of failure, how to restart it, and then what are the limitations of each and every tool. Okay, so if we understand the limitations also along with the features and debugging techniques, okay, we'll be in a position to decide which utility to be used in which scenario. Okay, so all are used for exporting and importing the data, but there are scenarios where you can determine a suitable utility to export or import. Okay, so by understanding all these features of each and every utility, you will be in a position to identify which tool to be used or which utility to be used. And then finally we have the performance tuning. Okay, writing SQL is not a big issue. Okay, anyone can write an SQL, but writing the correct SQL in an optimized way is required in any of the RDBMS, not only Teradata. Right? So in Teradata also, okay, as per the architecture, if we understand the architecture properly, you will have better understanding in writing SQLs. Okay? So those techniques will be discussed here, okay, to see the explain plan, to understand what the SQL is doing here, and then how we can make this SQL optimized, and how we can implement our join indexes, sparse index, aggregate index, the other index. We call them as other indexes, which are used for the optimization purpose. All these optimization related indexing concepts, statistics, explain plan, the join strategies, everything would be covered in performance tuning. And then these are the optional topics, because Teradata alone won't be sufficient for working as a Teradata developer. So we have to have some basic Unix commands. Okay, either one of the operating system we have to learn, either Unix or mainframes, because almost all enterprise versions of Teradata are installed either on mainframes or Unix. So it would be better if you know either Unix or mainframe, but learning mainframe itself is a big task. So here in these Teradata sessions, okay, we can give you an introduction of all the basic Unix commands which are required, okay, to execute the Teradata utilities, and how to see the logs, how to capture the log information during the execution in Unix. All those things would be introduced in this topic, Unix. Okay, and then we'll say general life cycle of a project, data warehousing project. Okay. So to help the people who are new to the data warehousing, they can leverage, okay, the general life cycle of the development project. Okay. So this course helps to get 3 years of experience as a Teradata ETL developer. Okay. All the topics covered can be used up to 3 levels of certifications in Teradata. Okay. So along with these topics, okay, if you go through all the documents, okay, and if you can go through some sample tests which are available on online, okay, you can go up to 3 levels of certification. You can attempt up to 3 levels of certification in Teradata. Okay. And we can help you in installation of the Teradata. Okay, we have to have a proper operating system to host this Teradata server, because the best operating system is XP Service Pack 3. But in case if you have Windows 7, which is a 64-bit, okay, then you have to have a virtual system to be installed and install the XP and then install Teradata. So we can help you, okay, with the guide. We have an installation guide for Teradata where you can go through each and every point and can install Teradata on your PC. Okay, so these are the topics which we are going to cover for the next 30 classes, okay, around 30 to 35 classes. So I'm opening the lines for you if you have any questions. You can please go ahead.
Hello, Manohar.
Yes.
Can I have your number?
My mobile number?
Yep.
May I know what is the purpose?
I mean, actually, I'm thinking to take the training. I think you're in India, right?
Yes.
Actually, I'm in California.
Okay.
So I just need your number. I'll talk directly to you. Okay.
Yeah, I mean, you can note down my email ID here. Okay, Manohar. My name is Manohar. As an organization presentation, I'm here. You can see this email ID and can drop me an email if you have any questions. I can get back to you. Okay, you can contact also. Yes.
Oh yeah. I mean, if you can provide me a number, then I can call you. I mean, just in 5 minutes or so.
What is your name?
Aditya.
Aditya. Okay.
Yeah.
Okay. Fine. I will be in touch with you. Yeah. If you have any other questions?
No. Where's your email ID? I mean, can I have your email ID? Manohar
Sun Manu. You can see here. sunmanu9@gmail.com.
TUNMANU9 at gmail.com, right?
Yeah.
Okay.
You can just put your